All right, everybody, good morning or afternoon, depending on what time you're watching this. This is, I know it's question 4 on our activity packet, but I'm going to actually do this one first because this is just like the front page of the activity sheet. That was the one where we had the treadmills. The price went from $14 to $1,600. We were working with that price elasticity of demand equation, the midpoint formula. So I'm going to start with this problem and then go back and do problem 2 and 3 and 5 after this. So, all right, so the first thing to remember is the formula for price elasticity of demand, the general formula. And remember that when we calculate these percentages, we are using the special midpoint or averaging formula. So you might want to, if you haven't done this problem yet, you might want to pause the video here, go write down the formulas, try the problem, see if you can calculate it, and then come on back to the video, press play, and check your answer. Okay, so I'll give you a minute to pause it. Not a minute, but a couple seconds, pause the video. All right, so assuming you've paused it, you've tried the problem, now we're ready to go and work through the solution. Okay. So we've got the information here. Dback tickets, price falls from 35 to 25. Quantity demanded rises from 24 to 32,000. So use the midpoint method, calculate price elasticity of demand. Dback tickets over this price range, show all your work. All right. So first thing you might want to do is just write down those formulas for price elasticity of demand. I'm going to kind of cheat. I've already copied them into my clipboard. Whoops, I don't know why those wacky numbers are on the left-hand side there, but I don't want that. There we go. We'll get rid of that. Okay, so here's our two equations. Ignore this stuff over here on the side. So here's our general formula. Price elasticity of demand is the percent change in quantity demanded of good X divided by the percent change in the price of that exact same good. So we're looking at the relative percent change in quantity relative to a given percent change in price. And again, how do we calculate these percentages? We're not going to do it the old-fashioned way. We're going to use this midpoint or averaging formula. So that is the difference in quantities like we would do the old-fashioned way. However, instead of just dividing by the original quantity or the original price, we're going to divide by the average of the two. So how do we get the average of two numbers? Add them together, divide by 2. So that's kind of why I wrote that out in the formula this way. Okay, so again, the average quantity, divide for dividing quantity, and then when you do get the percent change in price, divide by the average price. All right, so basically all we have to do for this problem is plug in, let's plug in our numbers, and we'll highlight this in blue. All right, so on top, we're going to have Q2 minus Q1. So Q2 is the 32,000, and Q1 is the 24,000. And then we're going to divide by the average of those two numbers. So you can add them together, divide by 2, or just kind of eyeballing 24 and 32. What's the midpoint of those two numbers? That's 28,000. Again, how did I get 28,000? You can add 32 and 24. That's 56. Divide by 2, 28. Okay? And then we're going to do the same thing down here for price. All right, so I'm going to plug in my numbers for price. P2, 25 minus 35. And then divide by the average price, which is going to be 30, right? Add 25 and 35, 60, divide by 2, 30. Or just, again, the midpoint, halfway between 25 and 35, that's 30. All right, so there's our numbers. Let's go ahead and simplify that a little bit. On top, we've got 8,000 over 28,000. And down below, for price, we've got negative 10 divided by 30. Oops, 30. All right, now we're going to plug in or calculate the decimals. So 8,000 divided by 28,000 is 0.285714. Repeating. So that's what's on top. Actually, I'll do it in the same format that I did up here. So there's our numerator, 8,000 divided by 28,000. On the bottom, we've got negative, that's 1/3, negative 1/3, so negative 0.33. And here's our answer, negative 0.86. If you got slightly different, probably due to rounding. Again, the most important thing is you follow this equation. You've simplified it here. You've gotten your decimals, then divide those two numbers. This is our answer, negative 0.86, or roughly somewhere around there. All right. So what does that mean? Is that 86 cents? Is that 86%? No. Negative 0.86, that is our elasticity. And again, the thing we want to focus on is not the minus sign, because remember, price elasticity of demand, you remember the law of demand, negative relationship between price and quantity demanded. So this number is always going to be negative. What we really care about is the absolute value of our number here. So the absolute value is 0.86. Again, what that means is if it's lower than 1, which our answer is here, 0.86, the percent change in quantity is lower than the percent change in price. That's how we would get an absolute value lower than 1. All right. So what does that mean then? That means our elasticity for this in this price range, demand for tickets is inelastic. How do we know that? The absolute value. Let's see. Oh, actually, I don't know that I have the straight up and down sign, so we'll use that. ED. We'll use that for absolute value. Actually, let's use this. That's a little bit better. Absolute value is less than 1, right? Percent change in quantity smaller than percent change in price. That means consumers are relatively less sensitive to that change in price, meaning demand is inelastic. All right, and now the last part, this actually should be, this was part A, this was part B, that should say B, not A, and this is part C. Should they lower ticket prices or not? Now, again, you've got to remember there's a relationship between elasticity and revenue. Since we know that demand is inelastic, remember the rule. Inelastic means people are relatively not sensitive to the change in price. So even though we'd be lowering price and quantity demanded goes up, inelastic means it goes up, quantity goes up by a smaller percentage than the drop in price. So we should expect that actually total revenue would go down if demand's inelastic and we lowered price. Okay? So if you want to raise revenue, when demand's inelastic, you should actually raise price. Let's do the math, and I'll show you why that is so. We're going to calculate revenue, which is just price times quantity. So we'll do that at each. Let's take those off at each price point. So actually, let's call this total revenue, quantity times price, right? The number of units we sell times the price of those units. All right, so at $35, the price is 35, and the quantity of tickets sold is 24,000. Okay, so that would give us total revenue of $840,000. Now, when we lower the price to $25, we're going to take, again, price times quantity, 25 times the quantity of 32,000. And our revenue is only 800,000. So again, you can see we did the math to kind of back up our answer. That when demand's, and that's again because demand is inelastic. Demand's inelastic, we lower price. The drop percent drop in price is bigger than the percent increase in quantity. Therefore, total revenue goes down when we drop the price. All right. I hope that made sense. If you have any questions, let me know. Next up, we're going to go back to problem 2. And we'll tune in for that. Thank you.